All right, so I made a little bit of a breakthrough while looking at this code. It's gotten a lot more complex, but we make the function and then we simplify it later. This, let me first show you guys. Um, Essentially, what I've done is I figured it out. It's embedded loops. Now, there might be another way through subsystems. I need to figure out what that is. But let me first show you the functionality. Then I'll go all the way back and I'm going to show you guys how to get here. So when I press run, as you guys can see, it does it only for 4, but that was just for the demonstrative purposes. If I add 5 and then I press reset, reset, continue, it will actually light up all 5 LEDs. So, how did I get here? Don't look at the time. It's 2 o'clock in the morning. That's totally fine. Essentially, I'm going to start from the beginning. Um, and to do that, first I'll save it just so that I always have it. But close in, close, get out of here, open up THRSim, open up a new file. I'll use this test and I'll delete. Yeah, okay. So we'll delete up to, what do I want to delete it? We'll delete all the way up to here. Okay. So what we have is LED. You guys know this. We're initializing our variables. We're starting to count. We're loading a variable of 1 and we're sending it to the register. And then we are storing, um, okay, I went a little bit ahead of myself. We're loading the value to accumulator A, and then we're storing that value to the register. Okay, so what do we do now? We talked about loops. Let's first have a delay between the first light turning on and then it's shifting to the left one. In order to do that, let's first have a loop. Let's call it loop Q. And loop Q, well, before we do that, let's first clear CLRA, the value that's stored in accumulator A, and then let's reinitialize it as, let's call it LDAA, and we're loading the value 255 into accumulator A. And now what we're going to do is we're going to slowly decrement it. But first we're going to do nothing by using NOP. And then we are going to decrement DECA, the value from A, and then we're going to check BNE if it is 0. And if it's not 0, then it will loop again until it's 0. So that's going to be happening for at least 255 microseconds. Let's double it. Let's load the value A again and do it again. So this doubles NOP. Okay, so it's important that you don't get too ahead of yourself. See, and whenever you copy paste, make sure that you're in the right tab. So let's see, just like that. But every time you have a new loop, first we need to label this loop Q. So both of those are loop Q. And now we need to have another loop. We'll call it loop W. You cannot have the same loop twice. I'm not sure if these are just labels or if they're actually, I'll do a little bit of testing to see if they're actually labels or if they're not. But for the purpose of this, let's just keep on labeling it different loops. So loop Q, loop W, the next one will be loop E, so on and so forth. So now we have the delay. So now, what are we going to do? We are going to use uh, accumulator B. So let's first load the value LDAB. We're loading the value 4 to accumulator B. Now, why am I doing 4? Because I don't want to use all 8 LEDs, to be 100% honest. I'm just going to be using 0 to 5. Yeah, so we're going to be using 5 LEDs. And I think that's going to be good enough to show the point. But what we're going to do, we are going to, now that it's loaded, we're going to shift the logic to the left. And it's going to be the logic from LED 1 and that's going to be our loop. So we're going to loop it. So loop E will be shifting to the left 1. And then we're going to decrease loop. We're going to decrease the value stored in accumulator B by 1. And then we are going to check to see if it's equal to 0. And if not, then it's going to, if it is equal to 0, then it's going to end the code. And if it's not, then it's going to repeat. So then this will be loop E. Now, as I said before, in order to have it change more than once, we will use embedded coding, or we're going to be using embedded loops. So within loop E, we're going to have another loop. We'll call it loop R. Let's say we're going to have it shift to the left, and then we're going to have a delay before it decreases or decrements. So we'll call it loop R. So for loop R, what we're going to do is we're going to reuse the previous loop, and we're going to have it do nothing. And then we're going to have it decrease the value in loop A. Oh, important to do. Let's see. Okay. Clear A. Load 255. Decrease to 0. Load 255. Decrease to 0. Now, we need to load 255. So I'm not really explaining this well, so I'll do it again. I'll make another video and I'll explain it if I'm not doing it perfectly. But we need to reinitialize 255 because as you see, we load the value 255 and we decrease it to 0. And once it's 0, we move on. We load 255 again and we decrease it to 0. And once it's 0, then we actually follow the logic of loading accumulator B. And then we're following the loop of shifting the logic to the left. But while it's doing that, let's also reset the accumulator A to 255. 200 LDAA 255. Okay, so in this loop, it's going to shift. In loop E, we're talking, it's going to shift to the left 1. It will load the accumulator value 255 to accumulator A. And then it's going to do nothing, then decrease the value of 255. And then we're going to have it check to see if the value is 0 in loop R. There you go. So it's going to load the value. It's going to shift the logic to the left. It will load the value 255 to A. It's going to decrease the value of 255 to all the way to 0. And then once that happens, then it will decrease the accumulator set to accumulator B. And then it'll check to see if it's 0. If it's 0, then it'll end the code. If it's not, then it will start again and reinitialize the accumulator A. And it will do so on and so forth. This is an embedded loop. In the practice of my code, I use 2 just to double the delay time. So we're going to just do it again. And it is a little bit, it's intuitive, but it's just a little bit, what's the word for it? It's a little weird, to say the least. But just through copy and paste. So essentially, it's going to repeat this function twice. It's going to set it to 255 and decrease it to 0. And if it does, then it's going to set it to 255 again, and it's going to decrease it to 0. And then once that happens, then it finally swatches over to the next LED. And then it follows this all the way down to 1, 2, 3, 4, 5 LEDs. So this is pretty much all the code that you need. And now we need to initialize 5 different LEDs. We're going to start at pin 0, and we're going to go all the way to 5. 0, 1, 2, 3, 4, 5. Okay, so now we're going to set it up like this. And when I run the code, what it should do, it should first show 1 and then go to 2, 3, 4, 5. I have 6. Maybe I should bring it up by 1, but we'll see what it looks like for the initial running. So there's an error. Okay, so there's already a loop R that exists. And that's because I just willy-nilly reset the loop. Okay, so as you see here, um, we have one loop bar and we have two loop bars. So let's just take R and change it to T. So now we have loop T. And now when I run this, let's increase the LDAB to 5. And we're just going to close it, reset, reset, continue. And as you can see, here we go. That's how you add that little delay. And it's through embedded loops. Now, through subroutines, I'm pretty sure what we can do is just call the subroutine. So we don't need to like have all these loops at the same time and it'll just happen the same. I need to figure out how to do that. But essentially what we're doing is we're adding a delay in order to actually um, have it so that you can see the LED as it goes from the left all the way to the right. And just showing it again, let's actually change the value to 4. I see that there's a couple problems with THRSim. Whenever you're doing your own experiments, please save each time. But in case you don't save each time, just know that if you run a code once, likeliness is if you run the code again, you might crash the system. So what you need to do, you need to change the code. You can even just change one digit. You see I changed from 5 to 4, and then you press reset. Then you say, yes, I do want to reset. Then yes, I do want to continue. And then you click your code, then you run your code. And as you see, then it works just fine. You press OK. If you want to just do another test, you set it to 5, and then you close this window, reset, yes, continue, and then you can run your code. And as you see, the delay is there. So that's how you do a loop. You use embedded loops. So for the next part of this project, I need to first have it go all the way to pin number 8, and then I needed to bring it all the way back to pin number 1. So it goes to the left, and then it goes to the right. Now I will use, I don't know which one I'm going to make a video first for, embedded or using substacks or using subroutines or shifting it to the right. Because it seems like it's not just LSR. It seems it might be a little bit tricky. But whenever I figure it out, I'll make a video and I'll let you guys know. And that's how you do the first half of your project through embedded loops. Thank you.